Hey algebra folks, welcome back. We're going to be continuing our lesson on completing the square. So we finished the first part in our last class when we talked about just very briefly how we could actually complete the square by finding our new c using our b over 2 squared, and then also how we can solve quadratics using the completing the square method. So we're going to take that a little bit further today, and we're actually going to see some more of the applications of completing the square and some more complex examples for completing the square. So our objective for today is by the end of class today, we can create a connection between the vertex equation and completing the square. So before we get started, why don't we actually try reviewing some of the concepts that we covered in our last class. And so you have a warm-up on this page with two questions. One is asking you to find a value to complete the square of the quadratic expression. And then the other question is asking you to use the completing the square technique in order to solve this quadratic equation, right? So take about 5 minutes and just pause the video here and work on these two questions. And when you're ready to go over them, press play. You finished? Ready to go over it? Let's go over it together. So for our first question, it says what value of k will make x squared minus 1/4 x plus k a perfect square trinomial, right? So whenever we're asked to complete the square of an expression, we just want to think about our formula b over 2 squared, right? And this b in this b over 2 squared is talking about my coefficient for my x term. It's talking about the b in my quadratic expression, right? So when I look at my expression, I see that my b is going to be -1/4, right? So if I just substitute that value in over here, I get -1/4 over 2 squared, right? And then you can just put this directly into your calculator. If you're having trouble putting this into your calculator because of the fractions, you can just do alpha, which is your green button, y equals, which is top left button, and then enter at the bottom right. And that's to make a fraction. Okay, so if you're doing it by hand, then you can just check along your work with me, but you end up getting -1/8 squared, and that is the same as, 1/64. Right, so this is your value to complete the square, so that should actually be what k is. So this is going to be x squared minus 1/4 x plus 1/64. Remember that whenever we complete the square, that value that we find to complete the square is always going to be positive, right? I'm going to take it one step further and actually just factor this as a perfect square trinomial. So whenever I'm factoring after completing the square, this is something that we had trouble with in our last lesson, but the form that you can always use in order to factor this is just x plus whatever you get as your b over 2, and then just square that quantity, right? So you just want to substitute in whatever you found for b over 2 in order to just factor this, right? So if I'm factoring x squared minus 1/4 x plus 1/64, what I'm going to just do is do x, and then I found out that my b over 2, when I simplified it, was going to be -1/8, because when I did -1/4 divided by 2, I got -1/8. So I'm just going to do -1/8 quantity squared. And that's going to be my fully factored perfect square trinomial. Let's move on to number 2. We're now asked to take this one step further by actually solving a quadratic equation by using the completing the square technique. So because we're going to have to use our coefficients a, b, and c throughout the entirety of this process, let's actually just take a minute and identify what those values are. So our a is going to be a coefficient for our x squared term. We also call it our leading coefficient. And because we don't see a coefficient there, we can assume that our coefficient is 1. For b, it's going to be my coefficient for my x term, which is -8. And then c is -7. So I'm going to do my first step where I'm going to just divide everything by my a. So my a is just 1, right? So whenever I divide anything by 1, I just get the same thing itself. So this doesn't change. This stays x squared minus 8x minus 7 equals 0. Now what I want to do is I want to take my original c, this -7, and just move it over to the other side of my equation. And the reason why I'm doing this is because I want to actually only complete the square on this expression that's left over, right? So because I started off with an equation that was in standard form, I'm going to end up with an expression that I can easily complete the square on, right? And so when I'm looking at x squared minus 8x, in order to complete the square, I want to think about my completing the square formula, right, which is b over 2 squared. And then I already identified that my b was -8, so I'm just going to substitute that in here. And so when I substitute that in, I get -8 over 2 squared. Once again, you can put this into your calculator, but I'm going to do it by hand because that b over 2 is going to be really helpful for me later on. So this is going to be -4 squared, and then this is going to be 16. So now that I've found my value to complete the square, I'm going to add it on my left-hand side of the equation. But remember, we're dealing with an equation, so whatever we add on one side of our equation, we have to add to the other to keep it balanced. So I'm going to add 16 here and add 16 here. So now that I've added my value to complete the square on both sides, what I want to do now is just actually factor this as my perfect square trinomial. And when I'm factoring, remember, I can just use this form to factor. So I'm just going to do x, and then my b over 2 was -4 when I simplified. So this is going to be x minus 4 squared equals, and then I'm just going to combine these like terms here to get 23. Now my last step is just to actually use my square root function in order to solve for x, right? So what I want to do is just try to isolate my x, but I see that it's in this quantity that's being squared, so I'm going to take the square root on both sides. So when I take the square root on both sides, I end up getting x minus 4 equals, and then remember, whenever we take the square root, we're going to have a plus or minus value, so we have plus or minus square root of 23. And then my last step in order to get x alone is just to add 4 on both sides to get rid of this minus 4. So that's going to lead to x equals 4 plus or minus square root of 23. And that should be our 2 solutions. So if you were struggling with this, that's okay. We're going to keep covering completing the square, and hopefully it should be a little bit more clear by the end of today's lesson when we wrap it up. So just to repeat, our recap of our last class was we learned how to complete the square and use a method to solve quadratics, like how we covered in our warm-up. And then we also talked about some of the pros of completing the square, right? So one pro of completing the square is that you can always use it to solve quadratics, while factoring doesn't always work. So it's always going to work whenever we're given a quadratic, right? And then we also noticed some similarities between the axis of symmetry equation, which was x equals negative b over 2a, and the equation that we use to complete the square, which, if you remember, is b over 2 squared, right? So we see that there's some kind of connection going on here. So we're actually going to go a little bit more in depth about what that connection is between that axis of symmetry equation and our formula that we use in order to complete the square, right? So when we complete the square, we can actually very easily convert our quadratic function into something called vertex form. And vertex form is just rewriting our quadratic equation so that we can easily tell what the vertex of our parabola is. And if we just want to refresh ourselves, when we have a quadratic graph, it's in the shape of a U, which we call a parabola. And this lowest or highest point is called a maximum or min, and that's always going to be a vertex. And remember, your vertex is a coordinate. So in your vertex form of a quadratic equation, right, you're subtracting your x coordinate of your vertex from x, and then you're adding your y coordinate of your vertex to your entire quadratic expression, right? And we can use the completing the square method to convert any quadratic equation to vertex form. And this is going to be really useful whenever we're doing modeling situations like real world word problems. And so this is a major benefit or advantage to using completing the square. So let's look at the first example where we're finding the vertex by completing the square. The first thing that we want to just notice is that when we are given this equation, right, this is actually a function. And the reason why this is a function, not just a regular equation, is because you have two different variables going on, right? You have an x and you also have a y, right? And so because you're relating two different variables to each other using that equal sign, this is a function, not an equation, right? But in order to solve quadratic functions, right, we want to kind of convert them into an equation that we know how to solve. So the first thing that we're going to do is just imagine that our y is a 0. So instead of writing this y when we're rewriting this equation, I'm going to write it as a 0, and then just keep everything else the same. Right? And then what we want to do is just go about our business of completing the square like we covered in last class, right? So I first want to just identify my a, b, and c because we're going to have to use them later on. My a is 1, my b is 6, and my c is 8. I'm going to divide everything by my a first, and I'm going to get the same thing because dividing by 1 just gives you the same thing. I'm going to get rid of my c so I can get an expression where I can complete the square. And so I end up with negative 8 equals x squared plus 6x, right? And then I'm going to use my b in order to complete the square. So when I use my complete the square formula, b over 2 squared, this is the same as 6 over 2 squared, which is 3 squared, which is 9. And remember, the whole reason why I write out those steps is just so that I can easily find out what my b over 2 is when I'm factoring. So what I'm going to do is just add my b over 2 squared on both sides. So I have negative 8 plus my b over 2 squared, which was 9, equals x squared plus 6x plus 9. Now what I want to do is just factor my right-hand side, right, where I have that quadratic trinomial, and then just combine like terms over here. So we have, remember that our form for factoring perfect square trinomials is just going to be x plus b over 2 squared. So I have x, and then my b over 2 squared was 3, so this is going to be plus 3 squared. I'm going to just combine like terms here, so I have negative 8 plus 9, which is positive 1, right? And what I'm going to do now is just actually reintroduce that y, right? So I didn't actually get rid of my y in the beginning. I just imagined that it was 0 just so it would be easy for me to complete the square. So what I'm going to do is actually just bring back that y and then put the appropriate sign in front of that 1. So this is what I end up with, right? I end up with y plus 1 equals x plus 3 squared. And so that's the equation that I'm going to bring with me to step 2. So in step 2, I have, let me just rewrite it here, y plus 1 equals x plus 3 squared. And what I want to just do is just isolate my y. So I isolate my y by just getting rid of any terms that are right next to it, right? So the only term that's right next to my y right now is this plus 1. So I'm just going to subtract 1 on both sides. And I get y equals x plus 3 squared minus 1. And that's actually our vertex form. So we have y equals x plus 3 squared minus 1. So now that we've gotten it in vertex form, it's actually very easy to find the vertex now, right? So remember, your original vertex form was y equals x minus h quantity squared plus k, right? And so this minus this h over here, as long as it's being subtracted, is going to be your x coordinate. I see that I'm adding 3, right? So my x coordinate for my vertex should actually be negative 3. It's going to be the opposite of whatever that value is. Then my y coordinate is going to be negative 1, because I can just take that y value at its face value. Right, so my vertex is negative 3, comma negative 1, and I found that using completing the square, and then just isolating my y. So on the next page, you have a check for understanding where you're finding the vertex by completing the square, right? You do not have to do each one, right? So just pick one and then just go with it. do your step 1, where you're completing the square. Step 2, isolate your y. Step 3, identify your vertex, right? So pause the video, take about like 3 minutes to just work on one of these problems where you're finding the vertex. All right, you ready to go over it? Let's try it together. So I'm just going to go over the first one, and then I'll go over the second one later on. So if you went over the first one, then let's try it out now, right? So I'm first going to try to complete the square, but I'm going to reimagine this function as just an equation. So instead of writing that y, I'm just going to write a 0. And this is just to help kind of simplify things when I'm completing the square. And so when I'm completing the square now, right, I need to be mindful of my a, b, and c. My a is 1, my b is 4, my c is 10. And I'm first going to divide everything by a, right? And because I'm dividing by 1, I actually just end up with the same original equation, right? Now I just want to move my c on both sides. So I'm going to get rid of that original c to get negative 10 equals x squared plus 4x. And then for my leftover quadratic expression, I'm just going to complete the square on this. And I complete the square by doing b over 2 squared, which is 4 over 2 squared, which is 2 squared, which we know is 4. So I'm going to add that value, 4, on both sides of my equation to keep it balanced. And so I end up with negative 6 equals x squared plus 4x plus 4. What I'm going to do now is just factor this as a perfect square trinomial. And remember that we can factor our completing the square by doing x plus b over 2 squared. So I'm going to do x plus, and my b over 2 simplified to 2. So this is going to be x plus 2 squared. And then this is still negative 6, right? And I'm also just going to reintroduce my y. So I'm just going to plop that y right in front. Now what I want to do is just solve for y. So I'm just trying to isolate y. And so I want to get rid of this minus 6 term. So I'm just going to add 6 on both sides. And then I get y equals x plus 2 squared plus 6, right? And if I'm thinking back to my original form for my vertex form, it's y equals x minus h squared plus k. And so my vertex is going to be negative 2, right, because I have a plus 2 there, and then comma 6, because that's where my k value should be, right? So I just found my vertex, and then I found my vertex form. Let's try out the other one, right? Same kind of thing, right? We want to first reimagine this y value as 0. So I'm just going to write 0 equals x squared plus 12x plus 34. And I want to find my a, b, and c. So my a is 1, my b is 12, and my c is 34. First thing, I'm going to just divide everything by my a value. So I'm just going to divide everything by 1. And I end up with the same equation. And then I want to get rid of the c value over here by subtracting 34 on both sides. So I end up with negative 34 equals x squared plus 12x. And so now what I want to do is just complete the square on this remaining expression here. So I complete the square by using my b over 2 squared. And then this is going to give me 12 over 2 squared, which is 6 squared, which is 36. So I'm going to take that 36 value and add it on both sides of my equation to keep it balanced. So I'm going to add 36 here and add 36 here. And so what I end up with is positive 2 equals x squared plus 12x plus 36. I'm going to use that general form that we use to factor perfect square trinomials. So that's going to be our x plus b over 2 squared, right? So I want to think back and remember what my b over 2 was, and I remember my b over 2 simplified to 6. So this is going to be x plus 6 squared. We didn't do anything to the 2, and now we're going to reintroduce the y by placing it right in front and adding the appropriate sign in front of the 2. So now I'm just going to isolate my y. So I isolate my y by getting rid of that plus 2. And I'm going to do that by subtracting 2 on both sides. And I end up with y equals x plus 6 squared minus 2. And so now I can identify my vertex. Whoops. My vertex is going to be my x value over here, right? So because it's plus 6, my x value for my coordinate is going to be negative 6. And then whatever this value is outside the parentheses is just going to be my y coordinate. So this is going to be negative 2. So this is my vertex, negative 6, negative 2. And then this is my vertex form. Let's actually try expanding our ideas of what we know about completing the square to example number 2, where we're completing the square when this time our a doesn't equal 1, and we're working in a real-life context. So let's just read the question together. You are planting a flower garden consisting of 3 square plots surrounded by a 1-foot border. The total area of the garden and the border is 100 feet squared. What is the side length x of each square plot? So we know a couple things, right? We want to just attack this using our no-need-plan technique, right? And this is a technique that we're going to cover in later problems as well. But let's just tackle what we know, right? So we know that the area of the garden and the border is 100 feet squared, right? So let's just annotate that. So we know the area of the garden and the border is 100 feet squared. So I'm going to write that down over here. Area of garden and border. Right. Another thing that we know is we were given a few expressions, right? So we were given expressions for the border and also the dimensions of each square plot. So we were given some expressions for border and square plot. And why don't we actually annotate our diagram so that it accurately reflects the expressions and the given information that we have, right? So we're not going to annotate that this is all 100 feet squared, but we do know that we have that 1-foot border that's going around our garden, right? So we know it's going to be 1 foot all the way around. So this is 1 foot. This is also 1 foot. This is also 1 foot. And then finally over here, it's also 1 foot. Another thing that I'm given is that these are square plots, right? And when we were covering our basic understanding of completing the square, we remembered that a square has equal side lengths on all 3 sides. On all 4 sides. And so we want to just accurately annotate that, right? And so in what we need to find, right, it tells us that our side length for our square plot is going to be x. So I'm just going to annotate this is x, 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 and this is x. Right? So these values represent the length and the width of our square plots. Right. And just to remind ourselves, another thing that we do know that we've covered before is that the area formula is going to be base times height. Right. So what we need to find is our side length x. So side length x of each square plot. Right? And so my plan of attack is that I don't know what my x is, right? But I do know what the total area is, and I have the dimensions of my square plots and my border. So I'm going to need to write and solve an equation that relates what I don't know, which is the dimensions, right? That relates to what I actually do know, which is the total area. Right? And so why don't we actually go ahead and try to write and solve that equation so that we can maybe use our complete the square technique. So let's actually go ahead and try to write and solve an equation that can be used to solve the problem. And when I remember back to what I know that to find my total area, it's going to be length times width, right? So we need to find some kind of way to write an expression for the length and the width. And I have my fully annotated diagram here, and I want to just see what's going on with the length, right? So my length, it seems like it's being made up of this border that's 1 foot here and 1 foot here, okay? So I have 1 plus 1 foot, and then I have this garden over here, which is x feet tall, right? So this is going to be 1 plus 1 plus x. I'm going to combine these like terms, and I end up getting x plus 2. Okay, so I found the length. Let's try to write an expression for the width. I notice that my width is made up of 1 foot here, 1 foot here, and then 3 x's, right? So this is going to be 1 plus 1 plus 3 x's, which I can just write as 3x, right? When I combine like terms, I end up getting 3x plus 2. And then my area is going to be, area is just multiplying these two expressions together, right? Because it's length times width. So we have x plus 2 times 3x plus 2. And we actually know that our total area is 100 feet squared, right? Because that was given to us. So we can just substitute in 100 for our area. We end up getting x plus 2 times 3x plus 2. Okay. What I want to do now, just because step 2 requires us to complete the square, I'm just going to expand this out. And so when I expand this out, you can take a minute to do the box method, but when we expand out, we're going to get 3x squared plus 8x plus 4 equals 100. And now I can actually just move into completing my square. So when I complete my square, I have 100 equals 3x squared plus 8x plus 4. First thing I'm going to do is just figure out what my a, b, and c are, right? So my a is 3, my b is 8, and my c is 4. What I'm going to just do first is just, well, what I can do is just subtract 4 first. I can subtract and get rid of that c on both sides, so I get 96 equals 3x squared plus 8x. And I know to complete the square, I need my a to be 1, right? And so what I want to just do is just divide everything by 3. And so when I do that, I get 32 equals 3x squared plus, equals x squared plus 8x over 3, right? And I complete the square by doing my b over 2 squared, right? My b over 2 squared is going to be 8 over 3 over 2 squared, which is 8 over 6 squared, which we can simplify as 64 over 36. I'm going to just simplify that a little bit more. I know that in simplest form it's just going to be 16 over 9. So this is going to be the value that I complete my square with. So if we actually complete the square, I'm going to add 16 over 9 on both sides. And then I want to factor this as my perfect square trinomial, right? So this is going to be x plus 8 over 6 squared equals, and then when I combine these two like terms, I end up getting this value 304 divided by 9. And so what I want to just do for step 3 is take that equation and just solve it, right? So I have x plus 8 over 6 squared equals 304 divided by 9. I want to just take the square root on both sides and get x plus 8 over 6, equals plus or minus the square root of 304 divided by 9. And then subtract 8 over 6 on both sides to get x equals negative 8 over 6 plus or minus square root of 304 divided by 9. Now, if someone were to tell you, oh, this is what the dimension of the square is, it wouldn't really mean much, right? So what we want to do is actually just approximate these so we can figure out approximately what these values would be, right? So remember, when we have plus or minus, we end up with two solutions. We have negative 8 over 6 plus square root of 304 over 9, and then negative 8 over 6 minus square root of 304 over 9. And then when we actually put these into our calculator, we end up getting around like 4.48, and then this approximates to negative 7.14. Now, when we don't have a real-world context, right, when we're solving quadratics, we end up with two answers, but we want to just think about what this answer really means, right? And so when we look back to what the question was actually asking us, it was asking us to find the side length x of each square plot. So when we found a value for x, it's going to represent a side length. We want to think about what kind of numbers can side lengths be. So side lengths can be, they can be decimals, that's fine. They can be really big numbers, really small numbers, but they can't be negative numbers, right? Because you can't have a negative side length. So when we review our two answers, we had 4.48 and negative 7.14. We can actually eliminate this negative 7.14 because it doesn't make sense in our situation. So our answer should be 4.48 as the value for x. So before we leave this lesson and just wrap up, this is an exit ticket, right? So what you want to do is just pick one out of these two. So just choose one of these problems. So choose one. And then for the second part that's asking you, do you understand completing the square? Right, I want you to actually go ahead and try both of these. So for both of these, this is really to understand whether you really get the full concept of what it means to complete the square and why we do it. Because while it is helpful to know how to do it, we also understand why we're doing it, so it's not so like pointless that we're learning this, right? So before you leave, this is what you should be completing. This is what you should be tearing off and turning in. And for the next lesson, we're going to go on to a new topic. We're going to go over something called the quadratic formula. And we're going to connect that to completing the square, since they're both very related to each other. And then we're just going to talk about all the methods that we've learned to solve quadratics and actually start comparing them and seeing why one might be better to use versus another in various situations. So your classwork, which is due for the next class, and that you should be working on later today during homework hour, is the second half of your day 13 problems. So you're working on 20, 26, 29, 43, 44, and 45. If you have any questions, make sure to talk to me, and we can arrange some kind of one-on-one conference so we can go over these problems together. Good luck.